So today's lesson is going to be on sketching planes. Um, it's a good skill to have because in the later lessons we're going to look at lines intersecting planes and things like that. So it's a good skill to have a visual in your head as to where this plane actually exists. So if I were to ask you, okay, sketch this equation x equals 4. Now, how you would actually do that depends on how many dimensions we're talking about. If it's one dimension, you'd simply put a point on a number line. If it's 2 dimensions, you would draw a vertical line. And if it's 3 dimensions, you would draw the YZ plane at the x coordinate 4. So really, this has lots of different meanings depending on how many dimensions you're actually working in. Now for this lesson, we're going to look at our Cartesian equations of planes that we learned about yesterday. And we're going to look at how to graph them. Now there are different skills, but it's very similar to how we would graph lines in grade 9. So it's actually not that challenging. So let's look at a couple cases. Case 1, we only have one variable. That means, for example, maybe B and C are 0. And in this case, D also equals 0. Oh, that's easy. If that's the case, then we're only talking about our xy plane. For example, if you had some value for z, or maybe your xz plane, or your yz plane. Now, if D wasn't 0, then you might have the equation, for example, x equals 5. So these two variables are still 0. We'll put the D on the other side of the equation. It makes it easier to work with in this lesson. So x equals 5. So how are you going to graph that? Well, these are just parallel to all these planes. So for example, x equals 5. Well, that is parallel to our yz plane, but we put it at the x coordinate 5. If you're to have y equals 6, for example, well, that's parallel to your zx plane, and we put it at the y coordinate 6. If you had z equals 6, well, that's parallel to your xy plane, and we place it at the z coordinate 6. Okay, let's get a little bit more tricky here now. Let's say we have 2 variables. So maybe just one of them is 0. And in our first case, we're going to make D 0 as well. What you're going to do is you're going to find a point with the missing variable set equal to 0. So, for example, here I have 2x minus y equals 0. All right, so let's find a point. Let's say x equals 1. If x equals 1, you can solve for y. Y would equal 2. So here's the point A, which is 1, 2, and 0. And then we're just going to connect it to the origin, and you're going to draw a plane parallel to that z-axis. Now the second case, or part B of the second case, is where D is not equal to 0. And there's going to be an example on the back of this page that we do that's just like this one. And what you're going to do is you're going to find the x and y intercepts and then draw a plane parallel to that missing axis. Right? So actually, let's go and do this example. It's example number 1 on the back. So before we look at case 3, let's go do that. So here we have a plane, 2x minus 5y minus 10 equals 0. Let me rewrite that. Let's bring the d coefficient to the other side of the equation. So we have 2x minus 5y equals 10. Okay, now we're going to find the x and y intercept. So let's start with the x intercept. The x-intercept occurs, of course, when y is 0. So we're left with 2x equals 10, or just x equals 5. So therefore, x-intercept is at 5, 0, and 0. Okay, well, let's find our y-intercept. Y-intercept is when x is 0. So we're left with minus 5y equals 10, which means y is going to be negative 2. So our y-intercept is 0, negative 2, and 0. So I already have the picture here because I can't draw with this thing. So the picture's been pre-placed. So here we have our x-intercept. So we draw the point at the x-intercept, draw a point at the y-intercept, we connect them, and then we make a plane that's parallel to our z-axis, because that's the variable that's missing in our equation. Okay, so that's what that one would look like. Okay, so case 3 then is when we have all three variables, so a, b, and c. Part A, we have d equal to 0. So that's this example that I have right here. Now, to sketch that, you're going to determine 2 points in addition to 0, 0, 0. 0, 0, 0 works because our d coefficient is 0. You can find any other 2 points. So in this case, for this question, if you were to set x equal to 1 and y equal to 0, you can solve for what z would be. And again, pick some random point and solve for the missing term or missing variable. And now we have 2 points, a and b. Connect them to 0, and then you have a nice triangle that you can extend outwards to infinity on that plane. Okay. Now, if d does not equal 0, we're going to find 3 intercepts and draw a plane through these 3 points. And that's the next example. So let's do that one. This is number B. Example number 2. And we're going to sketch this plane. So we have 2x plus 3y minus z equals 4. So if we're going to find the x-intercept, then we're going to make y and z equal to 0. So that means 2x will equal 4. And therefore x is 2. So our x-intercept is then 2, 0, and 0, which I've pre-marked right there. Do the same, find the y-intercept. That'll occur when x and z are 0, so we're left with 3y equals 4, or y equals 4/3. So our y-intercept is 0, 4/3, and 0. And finally, our z-intercept will be when x and y are 0, so we're left with negative z equals 4, and so z equals negative 4, which would be 0, 0, and negative 4. So I've drawn each of those points, and remember how we can define a plane. We can define a plane with 3 points, so just connect those points. There's your triangle, and you can extend that outwards to infinity again. So in our last example, problem number 3, we have 2 planes here, and we're going to find 2 direction vectors for the planes. So it's like 2 separate questions, part A and part B. Let's work with the first plane, so plane 1. All right, so for plane 1, you can look at, say, your x-intercept. You can probably see that pretty quickly. That's why it's easiest to put the d coefficient on the other side of the equation. So you can see if y is 0, you have 3x equals 12, or just your x-intercept would be 4, 0, 0. And similarly, your y-intercept would be 0, 3, 0. Now, if you have 2 points, you can get a direction vector. Right? So our first direction vector, say call it M1, is basically going to be, if this is A and this is B, A being our x-intercept, B being our y-intercept, our first direction vector would just be AB. Okay. We can write that as 0, -4, -4, 3, and 0. So there's one direction vector. But we need a second direction vector. So let me rewrite that equation. So we have 3x plus 4y. I want you to imagine the z term there, but it has a coefficient of 0. What that means is that there is no z-intercept. I mean, try and figure it out. If you set x and y equal to 0, you can't solve for z. 0z equals 12. You can't solve for z. There's no z-intercept. So if there's no z-intercept, well, that means the plane is parallel to the z-axis. And therefore, we can write a second direction vector as being any direction vector parallel to the z-axis. The easiest one would be 0, 0, 1. Okay, so looking at the second plane then. So we have x minus y minus 5z equals 0. Okay, so there's no d coefficient there. So we know, one, it passes through the origin. So passes the origin, which is coordinates 0, 0, and 0. Okay. Now, if we were to say set y equal to 0, the equation, so if y equals 0, the equation becomes x minus 5z equals 0, right? Which would be a line that cuts through the xy plane. And so I can pick points for that. I can find a point on that line. An easy point would be if x is 5 and z is 1. You would see that that would satisfy the equation. 5 minus 5. Right? So there's an easy point. Another thing we could try and do is we can set z equal to 0. And now we're left with the equation of a line which is x minus y equals 0. So that's a line that cuts through the xy plane. And certainly an easy point to pick on this one would be 1 and 1. That works. It satisfies the equation. So now we have 3 points. Okay? And we can get our first point, or our first direction vector, I should say, as if this is A and this is B, our first direction vector can be OA, which is just 5, 0, 1. And our second direction vector can be OB, which is just 1, 1, 0. And that's it for that lesson.